All right, welcome back. So last video we looked at compilation at the command line. We're headed back there to look at execution because again, it's the right place to do this because we can really see these two stages. Even if you use something like, IntelliJ or one of the terrible IDEs like Eclipse or BlueJ or whatever, those environments still jam these two steps together. And so this really is one of the best ways to see them separated. Okay, so back to the terminal we go. Welcome back. Let's do it. So we're back in the same directory that we were working in the first time. If you recall, we had some code in a file called example.java, and I'm going to go back and kind of replace this with hello world again. And I'm going to remove that class file. I'm going to compile my code, which takes a second. Then I'm going to look and see that the compilation produced this new file called example.class. And now we're actually going to execute stuff. So remember I said that there's this program called Java C that we're running. This is the Java compiler. That's what the C is for. I can use it to print off the version, and I've been using it to compile my source code into bytecode. When you're ready to run your bytecode, use a different program. And this is by design, and there's this really fun story that I could just launch into here about kind of the design of Java and where these ideas came from and how Java was going to take over the world and how it didn't quite happen and how JavaScript sort of came along, and it's a completely different language, but it took a different approach to things, and the web took off. And so now at the end of this very long, interesting road for these two languages, they're two of the most widely used programming languages on Earth, Java and JavaScript, despite the fact they have nothing to do with each other, and they have completely different design philosophies, and that's a fun story, and if you catch me in office hours, I will tell it. But we don't have time for that. So instead, what we're going to do is we're going to just run this other program that's designed to execute our Java code. And that program, conveniently, is called Java. I can pass the version argument to it, and you'll see it prints off a little bit more information than the Java compiler printed off. In this case, it prints off this is when this version came out, I guess, so March of this year. It's right about the time the pandemic was starting. I've got a little bit more about so this is a version of Java called the OpenJDK. This is an open source Java implementation. And that's information about the particular tool that we're going to use. But what do we actually want to do? We actually want to run that code that we compiled. And here's how we do that. Now, one of the things that's a little weird about the Java compiler is you would think that I would do this, and it doesn't work. Instead, what I need to do is I actually need to tell the class that I want to run, and now it works. Okay? So two separate steps, compilation, execution. Let's look at the consequences of those. So right now, when I run my program, it prints hello world. Let's change, and this is really important for those of you that came up with Python, because this is going to blow your mind. I'm going to change this to say hello there, and then I'm going to rerun my program. It says the same thing it did before. The output hasn't changed. And the reason is I haven't repeated that step of compiling the code. So I'm running on some level, the old output, right? I haven't rerun the compiler yet. If I rerun the compiler, takes a sec, now you see the updated output. So again, another way of kind of driving home these two separate steps. Compilation, which produces this bytecode, and then the running of the bytecode. The running of the bytecodes. One thing that, and again, I could demo this, but I'm not sure it really makes sense. This example.class file, this is a file. It's just got bytes in it. It's like any other file. You could attach this to an email, send it to anybody in the world who has Java installed, and they could run it on their own computer. That's kind of neat. So let's look at now the idea of an execution error. So we're really going to drive this home in the last sort of video that accompanies this lesson. This idea behind compilation, execution, development, production. So, let's look at an example of a compiler error, just to remind ourselves what that looks like. So I'm going to remove my class file. I'm going to remove the compilation output. And now I'm going to open my file, and I'm going to do some dumb mistake, and I'm going to try to run the compiler on that, and I'm going to see this compilation error. And you'll see that there is no class file produced. So if I try to run this class file, spell it right, it's going to say could not find it because there's no class file here because the code didn't compile. So when the code doesn't compile, I can't execute it. I've got nothing. So in order for the code to compile, I have to fix that mistake. Once I do that, then I can compile the code, and the compilation will produce output that I can execute if I spell it right. Bingo. Now, let's show an example of a runtime error. And this is so easy to do in Java because the compiler is dumb. So I'm going to create a string. I'm going to set it to null. And then I'm going to immediately take that string and try to print the length. This is not going to end well. I'm going to compile that code. Now, watch what the compiler does. Nothing. The compiler's like, okay, you said so. Doesn't seem like a good idea to me, but we'll try. In fact, the compiler doesn't even know whether that's a good idea or not. That's the problem, right? All right, so let's run the code. Same way we did before. Boom. Again, familiar error message to you from the playgrounds. Looks a little different, maybe. Actually, doesn't look that different. Null pointer exception. Some of you have seen these already because you forgot to check for null on one of our homework problems or something like that. Same thing. Now, again, what's so problematic about this is that, and I'll launch into a longer emphasis of this in the last video, compilation is something that developers do when they're building the program, testing it. So compiler errors are dealt with by people who are good at dealing with errors. Runtime errors, some of them happen in development. And particularly big software companies, they have huge infrastructure in place to try to catch as many of these types of mistakes as possible. So, before like Google releases a new version of Chrome, right? Or before Facebook, launches an update to their site, they have huge systems dedicated to making sure that it's not going to crash. And they'll try to do all sorts of crazy things to their systems, to make sure they don't crash in front of an actual user. A lot of these companies do in-house beta testing, so before they distribute to the world, they distribute an update to their own employees, because the idea is, somebody working at Google, if Chrome crashes for them, it's probably less of a problem. If someone's on the Chrome team and is actually a Chrome developer and Chrome crashes for them, again, less of a problem. So a lot of these types of bugs are caught during development, and a lot of software development places that do a lot of software development have really sophisticated tools for catching these, but they can sneak through and crash in front of a user, and that's really problematic. And so there's been a lot of work that's gone into figuring out how to take these runtime errors that just occurred. So that's a runtime error. It happens when I run the code. If I can transform those into compiler errors, then they happen during development in front of developers, and it's impossible for them to occur in front of a user. And so there's been a big push in sort of modern language design to do that, but I'll talk a little bit about that in the next video. So execution stage. I take the compiled bytecode, whatever it says to do, and I'm going to try to do that. And there are some errors that the compiler can check in Java. There's other errors that won't happen until the code is run. This is an example of one of the latter.